Hey guys, this is Miss Dupe. I am not here today, so instead of leaving you high and dry, I have a video for you. So we are working on comparing functions, and we are going to start off with number 1. You're going to write this on the packet that was given to you, and we're just going to do notes together on here. So the first example says 2 linear functions are given. So there's function 1, that's the table, and function 2, that's the equation. And then there's 2 questions off to the side. It wants to know if the slope of function 1 is less than, more than, or the same as function 2. And the second question is about the y-intercepts. Are they less than, more than, or the same? So you need to find those 2 pieces of information from the table in the equation. So slope of a table, if you remember, is change in y over change in x. So we need to look at our y's, and we're going from 400 to 410, which is going to be going up 10. And we're going from 0 to 1, which is going up 1. So our change in y is 10, and our change in x is 1, which simplifies to 10. For our function 2, it's actually really easy. You look at your equation, you figure out your m, which is 9. So we're comparing 10 and 9. So in function 1, 10 is more than 9, so that means you are going to fill in more than in the blank. The second thing we need to do is find the y-intercept. So in a table, our y-intercept is where our x value is 0. So as you can see, here is 0 right here. So our y value that is there in the table by 0 is 400. So our y-intercept of the table is 400. For function 2, our y-intercept is our b, which is 396. So if you compare 400 and 396, function 1's is 400, which is more than function 2. So in the blank, you're going to fill in more than. I know that kind of looks smushed on there. So that's example number 1. If you need to, pause this and fill this all in if you got a little behind. So in number 2, it says Lila and Dwayne each sell tickets at a concert. They start selling the tickets at the same time. Lila starts with 600 tickets and sells 10 a minute. The number of tickets T Dwayne has left after m minutes is represented in the table shown. Which statement is true? So as you can see, we are comparing functions, so you definitely are going to need to figure out your m and your b, or your slope and your y-intercept for each situation. So let's talk about our initial value, okay? Lila, it says she starts with 600 tickets. That's her initial value. Dwayne, if you look in the table, he starts with 600 tickets as well. So they both have the same initial value. They started with the same amount of tickets. The second thing you need to find is the rate of change or the slope. We're going to call this ROC, rate of change. So Lila sells 10 a minute, okay? That is her rate of change. So her rate of change is 10, okay? Dwayne's, we need to figure out from the table. Again, from our above example, our rate of change is change of y over change of x. Remember, rate of change and slope are the same exact thing. So we are going to figure out how many tickets Dwayne is selling. So he goes from 600 to 580. That is going to be going down by 20. And he's going from 0 to 4, which is going up by 4. For our rate of change of Lila, that's, going down 10 because she's running out of 10 tickets. So you can add a minus there. So you're going to go on your calculator. You're going to do negative 20 divided by 4 to figure out how many Dwayne is selling. You might be able to do that in your head. It's going to equal 5 or negative 5. So Dwayne is selling 5 per minute. So now we're going to look at our answer options now that we already have everything we need. It says Dwayne's average rate of tickets sold per minute is higher than Lila's. Well, Dwayne's is 5 and Lila's is 10, which is not higher, so that is not true. Cross that off. Lila's average rate of tickets sold per minute is higher than Dwayne's average rate. So Lila's is 10, Dwayne's is only 5. So that would be true. That means you're already finished with the problem. Okay? If we go to number 3, this one says a shipping company charges $5 for 5 pounds. Now, we are not using an add arrow tool because we're not doing this on the computer, so we're just going to graph it on the graph. So we already know they charge $5 for 5 pounds. So on the weight is 5 pounds on the bottom, and on the y-axis is $5. So we're going to put our point at 5 and 5. We need to find our slope for our graph, which is rise over run. As you can see, our y amount is 5 and our x amount is 5, which means we are going to keep growing 1 every time. So it looks like we're going to just keep going up 1 like this and then over 1. Up 1, over 1. And you don't have to keep doing stair steps, but you should just have a point at every single one. So you should have a point at 6, 6, 7, 7, 8, 8, and so on. So basically what this is saying is that the cost of apples is going to be $1 per pound. All right, going on to number 4. Number 4 gives you 2 functions, function A and function B. Function A is a table, function B is a graph. The question says create a linear equation whose rate of change is between function A's and function B. So if we look at function A, we need to find that rate of change first, which is change in y over change in x. We're going from 10 to 15, which is plus 5. We're going from 1 to 2, which is plus 1. That means we're going 5 over 1, which is 5. So function A's rate of change is 5. We have that right here. If we're looking at function B, the points are marked for you. So that is our rise over run. So we need to figure out how many up we're going and how many over we're going. So it looks like we're rising 1, 2, 3, 4, 5. And we are running 1, 2, 3, 4. 5 over 4. In this instance, since we're comparing two numbers, it's easier to compare them as a decimal. So in your calculator, do 5 divided by 4. And we're going to get a decimal of 1.25. There are multiple answers to this question. They want you to write a linear equation whose rate of change is between A and B's. So we need a number between 5 and 1.25. There are multiple answers for this. I'm going to go ahead and just say 3. So our equations are in the form y equals mx. You can add a b if you want to, but we can also just keep the b 0. So we're going to go ahead and just keep the b 0. So let's not use an equal sign. Let's use an arrow. Our equation is going to be y equals, we said the number between 5 and 1.25 would be 3x. You could use y equals 2x, y equals 4x. It just needs to be a number in between 5 and 1.25. All right, so number 5, it says a company has an old laser printer that prints pages at a constant rate as shown on the graph. The company buys a new laser printer that prints the same number of pages in 1/3 as much time as its old printer. Use the add arrow tool to graph the relationship between the number of pages printed and the time for the new printer. Obviously, we're not using the add arrow tool because we're not doing this on the computer, so we are just going to graph it on the physical graph. So if we look at our graph here, I already have markings on this graph. They have a point circled for us already, that is here. And this is showing that the printer is printing 12-ish pages in 20-ish seconds. So the new printer can print 12 pages, but in 1/3 of 20 seconds. So in your calculator, in order to find the amount of time the new printer takes to print the pages, we are going to do 20 times 1 ABC 3. You could also do 20 divided by 3 if you wanted to. And that's going to get you an estimate of about 6.6 repeating. We're just going to call it almost 7. So the new printer can print 12 pages out in about 6.6 repeating. So the new point that we're going to add on here, we're going to go to the y-axis where 12 is right here, and we're going to go over to about where 6.6 is, which is going to be like relatively close to 8. And then we will connect from 0 to there. And that will represent our line for the newer printer. And you can go ahead and just draw an arrow on the end there. All right, very last one, I believe. Oh no, we have 2 more. Number 6 says 2 companies manufacture pens. The number of pens Y company Q produces in X hours can be modeled by the equation shown. The number of pens company R produces per hour can be modeled by the graph shown. So we have an equation and we have a graph. The question is, based on the models, what is the difference between the number of pens company Q produces in 8 hours and the number of pens company R produces in 8 hours? So as you can see, we're going to be using the equation and the graph to figure out how many pens the companies are producing in 8 hours. The equation is going to make this really easy for us because we are going to plug 8 in for X. And then we can just plug that into our calculator. So we are going to do 150 times 8. And that's going to get us 1,200 pens. And this is company Q. Now, when we look at the graph, we are going to have to figure out our rate of change, which is rise over run. And so we are rising where that point is up to 600. And we are running over to that point, which is like about at 3. And then we need to go ahead and divide that in the calculator. So 600 divided by 3 is 200. And that's how many pens company R produces in 1 hour. So we want to know 8 hours, so we are going to multiply this by 8. And that's going to give us 1,600 pens for company R. So they want to know the difference, which the difference means subtraction. So we are going to do our bigger number, which is 1,600 from company R minus 1,200 from company Q, and that is going to give us 400 pens. So we got to make sure we're answering all parts of the question. All right, now we are truly going to our last one, which is number 7 on the back. let's see if I can read this. So this says, Roderick can water his lawn with a small hose on a large hose. Or a large hose, sorry. The small hose pumps water at a rate of 30 gallons a minute. So this right here is the rate of change for the small hose. It says the large hose pumps water at twice the rate of the small hose. Use the add arrow tool to show the relationship between time and the gallons of water pumped by the large hose. So this is actually pretty easy. Since we know the rate of change for the small hose is 30, the large hose pumps twice that. We are going to do 30 times 2, which is 60. That's our rate of change. We are going to go ahead and make a point at 0 first, because as no time has passed, no water is going to be pumped through. And then we always have an invisible 1 on the bottom for our rate of change. So our first point that we're going to plot, we're going to go up to 60 and over to 1 and make a point. So our second point, we're going to go up another 60, which will be up to 120 right here, and then over 1 to 2. So our second point will be at 2, 120. So we can only fit 3 points on this graph. Go ahead and draw a rough line here, add an arrow at the end, and that is what our graph will look like for the large hose. All right, good luck on your quizzes. Have a good day.